Okay, this is problem 47. A football player punts the ball at a 45-degree angle without an effect from the wind. The ball would travel 60 meters horizontally. A, what is the initial speed of the ball? B, what is when the ball is near the maximum height, it experiences a brief gust of wind that reduces its horizontal velocity by 1.5 meters per second. What distance does the ball travel horizontally? Okay. So, first we're going to draw our free body diagram without the wind. So, he punts the ball. Let's draw our X and Y axes. He punts the football. It goes 60 meters if there's no wind. Okay, so we get X equals 60 meters. All right, so, and it is punted at an angle of 45 degrees. So theta equals 45. And it is punted with an initial velocity, which we are looking for. The first part is find the initial velocity. A, find, this one is 47. Find V naught. All right, for this one, we're simply going to use the Rx equals V naught squared sine 2 theta over G. Okay, so in this equation, G equals 9.8 meters per second squared. We're looking for V naught. Theta equals 45 degrees, and the R of X is 60 meters. So we just plug them in. V naught equals the square root of Rx times G over sine 2 theta. All right, let's just double check, multiply, divide, square root. All right, good. So then we just plug in square root 60 meters times 9.8 meters per second squared over sine 245. Which will give us an initial velocity of 24.2 meters per second. So now what we have to do is find our V naught X and our V naught Y. So we can figure out how much of the distance was shortened by the wind that's slowing down the ball. Okay, so first things first, we will find our V naught X. V naught X equals V naught cosine theta. All right, V naught was 24.2 cosine 45, which gives us an initial velocity in the X direction of 17.1 meters per second. All right, but in this problem at the top, the X is disrupted. So we can make this V naught X 1, and then our V, which would make our VF in the X direction 1 is equal to that minus the 1.5 meters per second, which gives us scratch that. That is V naught for the first half, and then we'll make a V naught X for the second half. We'll just split it into 2. Remember, that's the 17.1 from the original minus the 1.5, which gives us 15.6. So we have 2 V naughts. So we're just going to split this in half. So let's draw another free body diagram. So now we have the football. What doesn't happen to the Y direction, however, is the wind doesn't affect it, right? So our Y direction is the same the whole way through. So our V naught Y is equal to V naught sine theta, which is 24.2 sine 45, which is also 17 17.1 meters per second. So it's launched upward at 17.1 meters per second. So if that's the case, when it's coming down, our VFY will be equal to negative 17.1 meters per second. Our acceleration is negative 9.8 meters per second squared. And our change in Y is 0, because it just ends up at the same height. And what we don't know between the two is time. So now that we have our velocities in our x directions, we can use our y direction variables to figure out the time. We can use a variety of equations. I'm going to use VFY is equal to V naught y plus AT. So we have negative 17.1 meters per second equals 17.1 meters per second minus 9.8 meters per second squared times t. So rearranging for t, we subtract 17.1, subtract 17.1, and then we get negative 34.2 is equal to negative 9.8 meters per second times t. Remember, this meters per second squared, this is meters per second, so the seconds when we divide by negative 9.8, we get t equal to 3.49 seconds. That is the total time that it takes for the entire y direction to complete. So going up and down, it takes 3.49 seconds. So if at halfway we get the gust of wind, we have two separate times to take into account, which would give us a time of we'll just round and make it 0.75, so t 1/2 is equal to 1.75 seconds. So that's going to be the t that goes in for both of these. So now we have to figure out the direction for the distance covered in the first half. So we get v naught x1 equals to x over t 1/2, which is, we're looking for the distance covered, x will equal v naught x1 times t 1/2, which will be 17.1 meters per second times 1.75 seconds, which gives us 29.9 meters. And then we have to solve it for the second half. V naught, remember this is, let me just finish this picture. This is v naught x1, v naught x2. And so v naught x2 will be equal to x over t 1/2. So x2, we'll call that x2. We'll call this x1. x2 is equal to v naught x2 times t 1/2, which would equal 15.6 meters per second times 1.75 seconds, which gives us 27.3 meters. So our x total would equal x1 plus x2, which would be 29.9 meters plus 27.3 meters, which equals 57.2 meters. And that's the answer. That's what we're looking for. Again, free body diagrams, variables, the work, using the correct formulas, and the correct answer. Oh, but this would be split into two, so these would be plus 1, plus 1, plus 1, because we have part A and part B. This is all part B. Okay, so For this one, the free body diagram would still be 2 points, 1 and 1, and then use the right correct one here, use the right math, right answer, that would be 5 points, 5 points. It would be split. The free body diagram would apply to both, so you'd get your 2 points for that.